Tekla Structures Masonry Tools, Lesson 2, Masonry Tool Basics, Part 2. Topics in this lesson include the discussion and use of the CMU Wall Tool, specifically placing and positioning masonry walls, adjusting various block wall attributes such as block type, course, or mark, applying configuration and block types to end conditions and bond beams, and adding and adjusting reinforcement. In this lesson, we're going to be focusing on the CMU Wall Tool. Specifically right now, in this portion, we'll be focusing on how to position a wall and the attributes of the overall wall in and of itself. And once we've gone through all the tabs in the dialog box, we'll then go ahead and add some additional walls to our model. As you recall, the CMU Wall Tool can be found in the Applications and Components side pane. To start, let's go ahead and activate the tool, and then come down to the right side of the wall we created in our previous lesson, and click that, and then extend all the way up into grid line C. Now when we select the wall, you'll notice that we select the entire wall, all the units and all the end blocks and half blocks and reinforcement that we've placed just by using the tool standard settings. Now we can select objects within components and again select the individual blocks and view its properties in the properties pane, but we're going to want to edit these blocks and control them through the dialog box. So if we switch back to selecting components and then double click on our wall or the icon in Applications and Components, it'll bring up the dialog box for us. And we have several tabs that affect the wall's physical features: wall attributes, end conditions, bond beam, bond M, beam rebar, vertical rebar, position, and tagging. In this section, we're going to focus specifically on the position tab first and then the wall attributes and how those affect the wall we've just placed. So let's take a look at the position tab. There are three fields that control the position of a wall we've placed: on plane, rotation, and at depth. Now each of them have a drop down. So for on plane, we can select left, right, or middle. And as you see when we do, the wall is actually going to move from side to side based on the points that we have chosen to place it. We can also add an offset on the right-hand side there on either direction using a positive or negative number, say 3 inches, and it'll move the wall off those base points in either direction. For the purposes of our tutorials, let's go ahead and place on plane to left with a 0-inch offset. Now rotation allows us to rotate the wall completely, and we can choose from 4 different positions: front, top, back, and below. And you can see here it'll rotate the entire wall. So if you actually have to do any kind of pavers or things like that, you can actually use the wall tool to accomplish that. But it does show the flexibility to rotate on the main axes just by using the drop down. Now if you notice we do below, the wall is actually considered upside down as we see the developmental bar on the top now instead of the bottom as it should. So let's go ahead and place that back on top. And we can also specify a specific angle as opposed to just using any of the cardinal directions, say 45 degrees, and we can modify that and it'll actually rotate the wall for us. So if you do have any instance where you need to provide a rotation of your wall, this is where you're going to be able to accomplish it. Let's go ahead and set our rotation to top at 0 degrees. Lastly, we have at depth, and there are some drop-down options as well: middle, front, and behind. Now this is going to move our wall vertically. So if we place it at the middle of the wall will be at the insertion points that we have, or the grips. If we do the behind, it'll be down below, and then front is what the default was. And again, with these attributes, you can also provide a numerical offset, a distance on the right-hand side there. Say maybe minus 16 inches to drop that down just a little bit. So you have the ability to go ahead and adjust the wall, even though it's been inserted on your grid elevation plane, and drop it down to account for foundation or stem walls. And that's pretty much the basics of the Position tab and how you can affect the wall. We're going to move on to the Wall Attributes tab, but before we do, let's go ahead to our View ribbon and open up our View list. And we're going to go open up Elevation on Grid 3, so that we are on plane for our wall we've just placed. Now the Wall Attributes tab controls a good number of things. It controls the course orientation. It controls the overall wall height. Also, what the staggering of our masonry units are, as you can see, 7 and 5/8, as well as what our mortar spacing will be. Default is 3/8 of an inch. These variables can be changed on the fly to suit any need, and you can see that we have the ability to adjust them after the wall has been placed in each parameter, simply changing the value, selecting the wall, and then hitting modify. Here we are changing the course orientation. Notice that the half blocks will move upward one course, or we can switch it back, and then our full box will be on the first course. In addition to the position and these features, we can also add the specific attributes, such as the shape, material, name, class, all very similar to the CMU block tool that we used in the previous lesson. In addition to those common, we have the ability to change the color or specify a color and provide the design name and group mark, as well as tagging blocks. Now, tagging blocks is incredibly important. If we change this from no to yes, this will actually tag each block that contains reinforcement, therefore signifying which ones at a minimum will need to be grouted. We can use this tag later on to filter out those blocks or change their representation very quickly. We still have access to the shape and material catalogs by hitting the select button, providing consistent access between the tools to those features. So for our demonstration, let's go ahead and select the CMU 8x8x16 shape. We'll leave the material at C60. We'll change the name to regular. The class can stay at 15, and our prefix will change to MB for masonry block. The height at 7 and 5/8, and let's go ahead and change the design name to reg, and leave the design group mark at CMU. And we'll turn on tag blocks. Just to reiterate, let's leave our wall height at 8 feet, our overhang or overlap at 7 and 5/8 inch, and our mortar gap at 3/8 of an inch. And go ahead and select the wall and hit modify. In this section, we're going to discuss end conditions and bond beams. If we go to the end condition tab, we can see that it looks very similar to the wall attributes tab. So much so that we have a diagram in which we can select a configuration for the different end conditions. Make note of the start and end point nodes down at the bottom of the images, and that the end conditions are highlighted in blue. So you have the choice of no end conditions, one on either side, or on both sides. In addition to the diagram, we also have 2 columns for our blocks, specifying both the half and the full blocks. These fields are identical to what we've seen on the Wall Attributes tab, as well as the CMU block tool. So we're going to want to connect the wall that we just created in this lesson to the wall from the previous lesson. For this particular task, we'll operate on the view named Elevation on Grid 3. Next, what we're going to do is go ahead and select the wall we've just placed, and right-click, and while holding down Shift, hit Hide. From here, what we can do is delete all the half blocks on the perpendicular wall. Then we can simply right-click and redraw the view. Now you can see that we line up perfectly. If this, however, does not line up perfectly for you, go back to the Wall Attributes page and change the course configuration. Now that we have this lined up with our perpendicular wall, we can go ahead and start to plan forward. On the right side of the wall, we are going to actually provide a seam, so we'll need some half blocks. On the End Conditions tab, we can drop down the diagram and choose the half blocks on the end of the wall. And then from here, we can go ahead and specify the attributes as shown on screen. Once we've populated the shape, material, and all the other attributes for both the half and full blocks, we can select our wall and hit Modify. Next, let's move on to the Bond Name tab and specify the courses in which we would like our bond beams. Notice there's a diagram provided with the numbering of courses. It numbers from lowest to highest, going from the bottom to the top. In the rows up above, we can specify which rows of our wall we would like bond beams placed. We place it by providing the numerical value of the row, followed by a comma and then a space, and then the next value, as shown on screen. As we've seen on some of the previous tabs, we also have attributes to affect the bond beam block in and of itself, so we can set this block shape independently. Let's go ahead and populate our bond rows at 4, 8, 12, 16, and 20. This way we'll have more than we need in case we need to raise the height of the wall. And let's go ahead and populate the attributes as shown on screen. Once we're done, make sure you're selecting the wall and hit Modify. Once you do, you can see that the bond beams have been changed to the color red and use the specified shape that we have provided in the dialog box. Additionally, you'll be able to see that they are located at every fourth course as specified. Once we have their main bond beams defined and applied, we can go ahead and switch over to the Bond End tab. This tab looks very similar to the previous, where you're only specifying the attributes for the end conditions of the bond beam only. So here you can denote what full block and half block shapes you would like to use specifically on the bond beams. Let's go ahead and populate the attributes for both the half block and the full block as shown. Once we've populated the attributes for the bond ends and applied them, we'll notice that the full blocks have an opening where we would like to provide a seam, or the end of our wall. However, we have the ability to rotate these blocks straight from the dialog box itself, and we can do this at either the start and/or the end of the wall. As you can see here, if we choose Swap Handles at End to Yes, it's going to go ahead and rotate those blocks 180 degrees so that they are in the correct orientation. So for your end conditions and your bond end conditions, if you find that your blocks are orientated incorrectly, this is how you can go ahead and correct that easily through the dialog. In this next portion, we're going to look on how we can place some basic reinforcement using the CMU Wall Tool. First, we'll start on the Beam Rebar tab in the dialog box. Now let's take a look at the Beam Rebar tab. This tab allows us to specify basic reinforcement horizontally in the bond beams. You may have started to notice a trend where we are having a diagram that controls the configuration, and then we populate the attributes to specify the specific points of what we're applying. We do have a drop-down image that allows us to choose 2, 1, or no horizontal reinforcement. At the top, we have the ability to provide the spacing between two bars if it's applicable, as well as the vertical spacing from the bottom of the bond beam up to the center of the bar. On the right-hand side, we're able to go ahead and specify the attributes of our reinforcement. The name of the bar that we'd like to specify, its size, grade, class, default clear cover. We can specify the max stock length, as well as the splice length for that size. Now, for the actual size and grade of reinforcement, we can select that from the Rebar catalog. When we hit the select button, this dialog box will pop up. On the left-hand side, you'll find the various grades available with the default installation of Tekla structures. Notice as we choose A61560, over on the right-hand side, we have a listing of various bar sizes available in that grade. Now, there are 2 entries for each size, one for main bar and one for ties or stirrups. As you're very much aware, the bending radius between main bar and then tie or a stirrup differs, so it's important to ensure that we're choosing the correct bar type, as we want it to be as accurate as possible to real-world conditions and fabrication needs. This is why the best practice in selecting bar size and material grade is to open up the catalog and select it, as opposed to typing in the field itself. This way, you ensure that you're getting exactly what you need. As you can see, the tool has already provided us some reinforcement as part of the standard loadout, but it does not align with the blocks that we've gone ahead and specified for our wall, so we're going to need to make some adjustments. First, let's start with the horizontal rebar, and to make things easier, we'll go up to the View ribbon and then select Clip Plane, and we're going to just select the end of our wall at grid line C and apply that clip, and then move it inward so we have the ability to see inside of our wall and the reinforcement we're dealing with. Now that we're able to see our horizontal reinforcement much better, we can go ahead and make the proper adjustments so that it aligns more accurately with the units that we are using. In the dialog box, let's go ahead and specify a vertical adjustment of 4 inches and take a peek on see how that affects. The horizontal bar is moved up, but it looks like we're still clipping some of the block, so let's add another 1/8 inch to that dimension and hit Modify. So you can see here, it looks like we have the proper clearance. Now, before proceeding forward, let's ensure that we populate the horizontal reinforcement properties as shown here on screen. Once we're done, make sure you're selecting the wall and hit Modify. Next, let's go ahead and adjust the vertical reinforcement for our wall. To apply vertical reinforcement, we just simply need to move over to the Vertical Rebar tab. Now there's a few areas where we can affect information on this tab. Up in the top right, we can specify our spacing, with both the initial start space off the start point of the wall, as well as the intermittent spacing there on out. And we can provide a single value that'll repeat, or a string of values to provide variable spacing. Below that, we specify the configuration or what bars we are going to create in the cavities of the block itself. We have the ability to choose from no bar, 1 bar, or 2 bars, and then we can specify up above what that spacing between those 2 bars is. To the right, we can specify hook properties if they're required. From the image dropdown, we can select straight leg or a hook either to the right or to the left. To the right or left is dictated by our position and our start and end points on the wall. The value fields that we can populate up at the top are the actual leg length of the hook itself. To the right, the top value provides the developmental length upward into the wall, whereas the value below that provides the extension of the hook itself below the wall, or into the foundation or slab or whatever may be located below. Then to the right, we can specify our parameters for our vertical reinforcement. These are very similar to the beam rebar parameters, with the addition of top and bottom cover. Next, let's go ahead and adjust the vertical reinforcement for our wall. As mentioned previously, this first dimension in the upper left is going to control the distance between our start point of our wall and the first bar placed. And this dimension is to the center of the 2 bars, if you're using 2 bars, or to the center of a single bar, as you can see here on screen. So we need to ensure that our starting dimension places our reinforcement centered inside the cavity. As shown in the dialog box, we have an initial spacing of 4 feet, which is going to repeat between sets of bars. We can change this to be a different value, or we can go ahead and actually provide multiple values so that the bar spacing varies or is irregular. And we would do this by providing a foot-inch value separated by a space, and then another value. When populating the dimension string, you can simply provide the foot or foot-inch dimension. So as shown here, 4 foot, 2 foot, 4 foot, 4 foot, and 4 foot. And you can see that it combined those several 4 foots in a row together with an asterisk, so 4 times 4 foot spaces. Notice, however, that when we provide a dimension string of variable dimensions, we only receive a finite number of bars placed, whereas one single value will populate for the entire length of the wall. So make sure to populate enough spaces for the length of your wall. However, let's return it back to standard 4 foot spacing. As mentioned before, we do have the option to provide no vertical reinforcement or a single bar, and then we also have an option to control which direction 2 bars are being placed inside the cavity. This allows users the flexibility to provide the vertical reinforcement as it would need to be installed. For the development downward, we could provide no development, and the bars will terminate at the bottom of the wall with the provided clear cover and the properties to the right. Or we can do a single straight development or a hook to one side of the wall or other. For our demonstration, let's go ahead and populate the vertical rebar tab as shown on screen. Once you've completed that, make sure to select your wall and hit Modify. Now that we've covered the functionality and tabs inside of the CMU Wall dialog box, and we have completed our first segment of wall, we are going to proceed to place additional segments of exterior wall using our grid and the CMU Wall tool. First and foremost, let's go ahead and save our settings. Let's call this tr_8inch_wall and hit Save As. This will allow us to come back to the general configuration we've already specified, and works the same way as the other tools and features inside of Tekla with save settings. For the next steps, we're going to add segments along grid lines 3, E, and 1, using grid line C as a location for seams as well as grid line 2. We will use the existing setting we have just created and make small adjustments to the end conditions as we go. So we're going to lay our next segment of wall. Let's go ahead and snap to plane by hitting Ctrl P and move to the end of our wall. We're going to hold down Ctrl and click the outside corner and then move perpendicularly upward. We're going to key in the distance 3/8 of an inch. This provides us a temporary starting point, 3/8 inch off the end of the last wall, and then we're going to snap perpendicularly to E-line. Once we do, we've placed our second segment of wall and we can see how that looks. Now that we have this segment placed, let's make a few adjustments. First and foremost, we're going to double click on the wall and we're going to go to the End Conditions tab and we're going to change our end conditions so that we have half blocks at our starting point and at our end point. Select the wall and hit Modify. Secondly, let's go to the Wall Attributes tab and then change the course configuration from the image dropdown so that it aligns with the previous segment. Now we will extend the end of our wall segment at least 6 inches past the grid line E so that the final blocks rest as shown on screen. To do this, select the wall and then click directly on the magenta endpoint. Right-click, select Move, and then snap perpendicularly upwards or key in a distance greater than 1/2 of the block, or 7 5/8 of an inch. This will extend the wall another half block so that it terminates on top of grid E. Before we proceed, let's go back to our walls we made with the single blocks and remove those full blocks we added for the return, as they will not be required when we place the wall segments along grid line 1. Next, we can select these two wall segments we've just placed, right-click and select Copy. We're going to pick the base point, as shown on screen, place them at the intersection of A and 1 at the edge outside corner of the block. From here, we can double-click on the wall segment and open up the Position tab and change the on-plane value from left to right. And let's do this for both segments. One quick and easy way is to deselect all checkboxes and only apply the on-plane by selecting that one single checkbox. By doing so, you can see none of these values are checked, but we do want to go ahead and update our wall attributes as well for the course configuration. Once we've set these parameters, go ahead and select your wall and hit Modify. As you can see here, both have been updated. For the segment between C and E on grid line 1, we're going to go ahead and eliminate the end conditions at the end of the wall. Make sure to check the checkbox next to the image dropdown on the End Conditions tab to ensure we are applying that property. And we'll do the same for those on grid line 3. That way we have open ends and can form corners with the perpendicular wall we're about to place. Once both segments along grid line 1 and 3 between grid lines C and E have been placed with open ends, then we can place the final two walls along grid line E. Our starting point will be the upper outer corner of our previous wall at grid line E and 1, and we will snap perpendicularly to grid line 2. Once we place the first segment between grid lines 1 and 2, we will need to make adjustments to the wall. First, let's change the direction of the vertical bar hooks for the outside wall so they're pointing outward from the structure. Secondly, let's go to the Position tab and change the on-plane from left to right. We'll go to the Wall Attributes tab and change the course configuration and hit Modify. That should line us up. Now we just need to repeat the process for the last segment of wall between grid lines 2 and 3. Again, we can do this by clicking the previous segment of wall as our starting point, but holding down Control to place a temporary point. Then we'll move our cursor out perpendicularly and key in 3/8 of an inch. Then, for our endpoint, we'll snap to the end outside corner of our previous wall. From here, all we need to do is adjust our end conditions for the segment, and we have completed our exterior walls for this lesson. The CMU Wall Tool greatly increases efficiency and productivity of users creating masonry walls. In our next lesson, we're going to cover the remainder of the masonry tools, such as the opening tool and perpendicular corner connection tool. This concludes Lesson 2, Masonry Tool Basics, Part 2. Proceed to the next lesson, Lesson 3, Masonry Tool Basics, Part 3.